Biology is a lot more complicated than one might suspect. We tend to look for linear solutions, binary solutions, A leading to B, but obviously biology is more than that. Evolution is a lot more tricky than that. You see a lot of the non-linear stuff that you wouldn't really anticipate ahead of time until you do the studies. And I think that's one of the take-home messages about the importance of doing investigator-initiated basic research. We obviously ultimately want to get the drugs that will help treat these diseases people are suffering from. But I think it's becoming clear, very apparent that to be able to get these nuggets, these discoveries, you really need to do upfront all the tremendous amount of work that goes on. And then there's that element of serendipity, right? And I think that's what we're looking for. I recall reading a book by that title, and it's just amazing to see how many scientific discoveries came about just completely out of the blue. Obviously the biggest example is penicillin. So, and there is a bunch, this book lists one discovery after the next. So I think it's this marriage between, really smart investigators doing what they love best and what they know best, and waiting for this element of chance, of serendipity to come up with these discoveries that we're looking for. We've also had some success stories more related to the disease processes, cataract in particular. That's the lens that's the program we're talking about. A recent story that about a few months ago now that came about that actually somehow linked the cholesterol biosynthesis pathway potentially with cataract. And so, and it's actually two different teams pretty much started out their journey with very different approaches, and yet it's interesting to see how they converged on the same outcome, the same result. One of these teams had found this family that had a cataract among the siblings, and when they analyzed the mutation, isolated the mutation, turned out to be in the cholesterol synthase gene. And from that, which is really kind of came as a surprise, because you wouldn't think that this is a key enzyme in the biosynthesis of cholesterol. When they analyzed that, and they actually they did a bunch of different really cool experiments, but I'll highlight one. They just take lenestrol and simply put it as an eye drop on in a canine model of some dogs that had cataract, and the severity of the cataract went down significantly simply by giving a drop. And now this is a proof of concept study, right? And it remains to be seen if it translates to humans. But if it does, imagine down the line when ophthalmologists are able to simply prescribe a drop instead of doing, needing to do surgery, which is the standard operating procedure currently. There's another aspect to that. Cataract is actually one of these diseases that's considered or belong to a family of diseases where it's called the Proteopathies, which essentially means the proteins that somehow get misfolded, right? So it's a misfolding disease, right? And there are a number of examples like that, such as Alzheimer's disease, Parkinson's disease, ALS, more related to the RP. So a lot of these diseases are really a core defect is these aggregations that take place. If you're able to come up with this, with a drug, an enzyme, something that's able to target these misfolded proteins and be able to reverse that. And this study that I just mentioned clearly shows that it's possible, at least in a specific circumstance. Again, it's not clear yet how widely applicable that will be, but it's really tantalizing evidence that it might lead to something much bigger. There are a lot of findings that one obviously starts out interested in understanding lens biology and pathobiology, but it's amazing how many findings over time that actually translated outside the lens, including the rest of the eye, and actually even outside the eye for the rest of the eye, the body. So it's really fascinating to see. We were talking a bit ago about the serendipity, and that's part of it. So I think obviously ultimately the main goal is to solve this disease, really, this horrible disease. This had huge global public health burden. And so how do you deal with that? So it's really a combination of that. There's another big element, which is presbyopia, and that is the loss of accommodative ability. And essentially every single one of us, if we are lucky enough to age, we will develop it. So it's a very prevalent disease, and so we don't really know much about it, right? The more of the research that I've been describing to you that have been funded by NEI and elsewhere really has focused more on cataract. But presbyopia is another really important public health issue. I think that's one of the areas that would be great to see some more traction on that, just because of its significance and relevance. Nothing NEI funded, I should say. There are some trying to understand the basic biology of that. Or we have a project funded actually in a non-human primate model. But I think more work is being done in the industry, trying to develop more specifically some of these accommodating lenses, these artificial lenses, the IOLs. And so there is some work going on. But I think when you look at how the burden of disease, in my opinion, I think there is justification for even doing even more work.